Hi everyone, in this lesson we're going to be looking at using a formula to find the area of a triangle. And that formula is right here. It's A equals 1/2 AB sine C. The area of a triangle can be found using that formula where A and B are two sides and C is their included angle. So in other words, we have a side angle side scenario. We have two sides and we have the included angle, which means the angle between those two sides. So this first scenario here where I have a big X, this wouldn't work because we have angles side side. Right, so it says find the area of the given triangle. So we're gonna look at this triangle I showed in my example. We're gonna write out the formula. Now that formula can be used, it doesn't have to be sides AB and the angle C. It could be any of the two sides with the included angle. So in this case, I'm going to write out the formula and it's going to be 1/2. And the sides we have are across from A is side A, across from angle C is side C. So we have AC sine of angle B. Right, so it doesn't matter how the angles and everything is labeled in the triangle. As long as you have side angle side, you can use the formula. So we have 1/2. Side A is 7, side C is 5, and angle B is 115 degrees. And so we're just going to put that in the calculator. Now, when you put this in your calculator, just make sure that you're in degree mode. We have a degree symbol, so we know that we're working in degrees. If there is no degree symbol, then we know we're working in radians. All right, so let's open up the calculator. Let's make sure we're in degree mode. And my calculator is not. You can see at the top, it says radians. At the top of your calculator, if you have the newer version, it should show you degrees or radians. To change the mode, you're going to go to mode, press the mode button, and you'll scroll down, and we're going to highlight degree, and we're going to hit enter. Okay, now we're in degree mode, and now we can go ahead and enter in our formulas. We're going to get 15.86. So the area of this triangle is approximately 15.86. All right, moving on to example 2. We don't have anything labeled, and if you really understand how the formula works and you don't feel the need to label, that's fine. I'm just going to go ahead and label it. I'm going to call this angle A, B, and C. Across from angle A is side A, across from angle B is side B, and across from angle C is side C. And I didn't mention this in example 1. Just notice that the angles in geometry are always named using capital letters, and the sides are always named using lowercase letters. All right, so I'm going to be looking for angle, I'm going to be using angle A here. So the formula that I would be using would be 1/2 BC sine of A. And then we'll just fill that in. So if we put that in our calculator, we're going to get that the area is approximately 19.32. Right, so now we're going to take it up a notch. I assume that you are good at, copying down a formula, filling it in, and putting in your calculator. There's really not much to that. So we're going to take it up a little notch now with this problem. It says, find the value of x when the area of the triangle is 5√3. All right, so nothing changes. We see that we have this side angle side scenario. So we know that we can use the formula that we were using on the last page for the area of the triangle. Right? So I'm just going to label this. I'm going to call this A, B, and C. Across from angle A is side A, across from angle B is side B, across from angle C is side C. All right, so I'm using the formula where I'm going to be using the sine of angle A. So I'm just going to write out the formula first. It's going to be 1/2 BC sine of A. Now, I already know that the area of this triangle is 5√3. I know that side B is 2x plus 1. And I know that side C is x plus 2. And I'm putting down the sine of 60 degrees. Now there's two ways to approach this problem. We can do it algebraically, which I will do, or we could do it using the calculator. So I'm going to show you how to do it algebraically first. And the first thing that I notice is that the sine of 60 can just be converted to a number. If you know your unit circle, the sine of 60 is root 3 over 2. So let me rewrite that because I'd much rather see root 3 over 2 than the sine of 60. I'm just going to put it next to the 1/2. So let me just make a little note here that this sine of 60 is root 3 over 2. And then I'm going to FOIL out the 2x plus 1 times the x plus 2. And when I do that, I'm going to get 2x squared plus 5x plus 2. Right, that already looks a little bit better. So what do I have here? I have 5 root 3 equals root 3 over 4 times 2x squared plus 5x plus 2. And I want to solve for x, so I'm going to multiply both sides by 4 over root 3 to just, try to isolate the right side of the equation. So, all right, now, on the left side of the equation, when I multiply 5 root 3 times 4 over root 3, the root 3's are going to cancel, and I'm going to end up with 4 times 5, which gives me 20. So on the left side, oh, looks so much better, right? I have 20. When I multiply 4 divided by root 3 times the right side, the root 3 over 4 is going to go away because that just becomes 1. So the right side becomes 2x squared plus 5x plus 2. Oh, so much better. Now I need to get 0 on one side, so I'm going to subtract 20 from both sides. And now I'm going to factor 2x squared plus 5x minus 18. And I'm going to solve for x. And when I solve for x, I'm going to get -9/2, and I'm going to get x equals 2. Well, when I look at the problem, -9/2 does not work in the context of this problem because if I put -9/2 in there, I'm going to get a negative number out, and you can't have a negative length of a side. So I know that this guy doesn't work, and this is my answer. Now, that was a lot of work algebraically, and if you were taking a test and you had your calculator, I think it would be much easier to just put this into your calculator. So what we would do in that case is we're going to put the left side into y1, and we're going to put the right side of the equation into y2. And it could be vice versa. You could put the right side in y1 and the left side in y2. It doesn't matter. And then we're just going to find the intersection. So let's do that next. All right, so you can see that I have entered in the left side and the right side of the equation, and I'm confirming by looking at the top of my calculator that I am in degree mode because we do have a degree symbol, so we know we're in degree mode. So now we're going to look at the graph. I'm going to do zoom 6 for a standard window. And now I can see the graph. Now, knowing the problem, I know that a negative value is not going to work in the context of this problem, so I'm not even going to bother finding the left side intersection point. I'm just going to look at what is the right side intersection point. And we already know the answer is 2, but we'll just confirm it. So we're going to go to second calc, number 5. We're going to move our little spider near the intersection that we want to find. We're going to hit enter, and hit enter again. And we get our intersection point is x equals 2. All right, so that was a much easier process, I think, to find the solution here, but I wanted to show it to you both ways. The IB exam is going to be, one part is going to be calculator allowed, and another part is going to be no calculator. I am thinking from all my experience of looking at past IB exams that this type of question would be calculator allowed type of question. So, but you learned something either way. All right, moving on to example 4. Find the area of a regular pentagon of radius 3. And we're going to use this formula again for the area of a triangle that we've been looking at. I'm just going to mark up my pentagon. I'm going to find mark at my center. And I'm going to draw all the radii. And it's telling me that the radius is 3. So all these are going to be marked up as 3. And then, of course, this pentagon is inscribed. You imagine that is inscribed inside a circle. And so all the way around would be 360 degrees. So to find these central angles, I'm going to do 360 degrees divided by 5. When I do that, I get the value of the central angles of this pentagon, which is 72 degrees. So all of these angles are 72 degrees. All right, so we have our picture marked up. Now, we're going to just look at one triangle. I'm just going to look at this guy right here. I'm going to redraw it. Put it right here. Just a rough sketch here. And I know this is 72 degrees. And I know that these are both 3. So I have, again, my side angle side scenario. So I can find the area of that triangle, and if I multiply it by 5, then I'll know the area of this pentagon. Right, so I am going to label and mark up my picture here. So the formula that I'm going to need, I'm going to write this out, the area of one triangle in the pentagon. It's going to be area equals 1/2 AC, the sine of B. Right, so in this case, the area is going to be 1/2 3 times 3 times the sine of 72 degrees. Okay, so let's put that in our calculator. All right, I get that number, 4.279754,323. And I want to leave that. I'm not going to try to round that number. I'm going to take that number now. I know that's the area of one triangle, and I need to multiply that by 5. So I'm just going to do that now. I don't want to round anything till the very end. All right, so my final answer rounded now would be 21.40 meters. All right, that's all I have for this lesson. Hope you enjoyed it. Have a great day.